Clarissa Chong. I'm a fourth-year computer science major at the University of Florida, and I am the current webmaster and one of the workshop leads for WiCSE. And this is my Intro to Game Development series. Today's agenda, I'll be going over the workshop requirements, what is game development and common game engines, tile maps, sprites, animating sprites, Godot scripts, and some tips. So for this workshop, we'll be using Godot. The dialogic manager is for the second workshop. This is the GitHub link that I'll mainly be working with. So, game development is a multidisciplinary collaborative process of designing, creating, and releasing interactive entertainment. There is around 3.32 billion gamers worldwide, and in the US market alone, it generates $60.7 billion in revenue. And there's also hundreds of game engines, most popular of which is Unity, followed by Unreal Engine, Godot, and GameMaker. Godot is a free open source game engine released in 2014 and developed by Juan Leonetsky and Ariel Manzar. The main programming language is GDScript, which has a Python-like syntax. It has C# support and uses C++ for engine extensions. It also supports visual scripting and is dynamically typed. The reason why I chose Godot is because it is lightweight, minimal, and has a built-in editor. It is also node-based, and has built-in physics, animation, audio, etc. And there's also no royalties. So why I chose Godot over Unity, even though Unity is like the industry standard, is because Unity announced runtime install fees in 2023. There was a lot of poor communication with sudden policy changes, which broke trust with indie and small studios. So many developers transitioned to Godot instead, and Godot is gaining like a lot of popularity in recent years. Tile map is a node for creating grid-based 2D maps, where each tile is a small texture, and this is ideal for levels, backgrounds, and repeating patterns. Tile sets define your tiles and their properties, and this includes collision shapes, occlusion navigation, and animations. Some other features it has is that tiles can have collision shapes for physics, and multiple tile maps can stack for parallax or effects. It also supports animated tiles as well. Alright, so for our tile maps activity, we'll be going to Godot here. We're creating a 2D world. This world, I'm going to add a child node. I'm going to add a tile map layer. So tile maps, it requires a tile set, so I'm going to add a new tile set. Go to tile set, and then add the assets. And then click yes. And now I'm going to paint into the map itself. So I'm going to select the tile that I want to paint with, and then use the rectangle tool to drop in a quick texture. And I can change to the tile that I'm working with, and then add it to the bottom row. Add in that corner. And then the sides. And then if I want to add in any new textures that's not grass, I can simply go back to tile set, click on this plus icon, click on Atlas, and then to the water PNG. All right, and then back to tile map, I can just simply select the water that I want and then paste it in. And I'll kind of round this out a little bit. Oh, it's so much. Well, you can see there's a little gap here, so I'm going to click this fill bucket tool and fill that in. And yeah, so we can run this scene. I'm going to select current. Actually, I'll save this to a new folder called scenes, and then later we'll have a folder for scripts. All right, and then I'm going to click run again. Select current, and then save this world.tscn, which is our scenes file extension, and save it to our scenes folder. All right, so game has started, and we can see our little thing here. So, sprites. Sprites is the visual representations of 2D game objects, and they're used for characters, items, backgrounds, UI elements, etc., and the textures are also imported from images. In Godot, I'm going to click on this root node here, the world node, and I'm going to add in a character body 2D. And as you can see, there's a little error here since it has no shape. So I'm going to add a child node onto that, which is the collision shape 2D. There's also an error, which means that we need to add this shape here. So empty, we're going to click on rectangle for now. And now we want to add in our actual sprite. So add child node and then animated sprite 2D. There you go. So a sprite's frame resource must be created or set in the sprite frames. So we want to create a new sprite frames and then refresh this node. And as you can see, this sprite frames tab is now on the bottom of the screen. So we're going to add the assets that we want. We want an idle asset looking towards the left. Idle, I'm gonna copy this to the right. Oh, idle to up, and then idle down. And then I'm also gonna add for walking. So walk up, copy this, walk down, walk left, and then walk right. And now I'm gonna add the actual animation frames. So starting with idle down, I'm gonna click on this little grid pattern here, go to assets, characters, and then this character sprite sheet. And this is something that I found for free on the internet. You can use whatever you like. So I'm going to click on the idle down sprites, which is these front two. And I'm going to basically do that to all these animations. So I'm going to quickly go through them. Grid, this is idle left, so this one's. Idle right is on the bottom. Idle up is up here. And then the walk down is going to be the third and fourth columns, so these ones. Left is these ones. Right, and then up. All right, so those are all of our animations. We're gonna start writing a script uh, to code like the movements. But actually, first, I'm gonna show you what the animations look like. So, for example, if we are doing walk down, I'm gonna play this, and you can see that it's the little character is moving. I'm also gonna click on, let's say, idle down, and look, it's like hopping a little. Yeah, so now we're gonna write the script for this. So I'm gonna click on this character body 2D node. I'm going to actually rename it to player to easier differentiate what our nodes are. And then I'm gonna add a script. And then I'm gonna put this in the scripts folder. Okay, so for our scripts, this kind of tells us what the nodes the script is on. So we are extending from a character body 2D, which is the player here. We are going to define the speed to be 300. We don't need jump velocity, and I'm going to remove all of this in the physics process. I'm going to put in pass for now. So first off, we need a reference to our animated sprite 2D so we can call the animations later on. I'm going to create a variable on ready var animation is equal to this animated sprite. And since it's just in the hierarchy of the player itself, I can just say the name without any path. Okay. Now I am going to define a variable called direction, and that's going to look at the vector 2.0. And then I'm going to take in an input. So whenever I press certain keys, it moves accordingly to what keys I pressed. So I'm going to do if input is action pressed, and I'm going to say move left. Then direction of the x coordinate is decreased. And I'm going to copy and paste this for all of the other actions. Just move up, move right. Actually, I'll put this as right. Move right, move up, and then move down. Uh, so with x coordinates, with move right increases. For moving up, it increases here. And then the y coordinate decreases when moving down. Yes. Now we want to add to our project settings the input map. So we go to project settings. I'm going to increase this. I'm going to go to input map and this is all gone. Uh, so we're going to add in new actions and these match to whatever action is we put that in there. So move left, move right, move up, and then move down. And the way we map the keys is that we select a certain action, we add an event, and then we select the key that we want it to map to. So for move left, I'm going to select the left key on my keyboard and add it. Move right, I'm going to select the right key and add it. Move up, I'm going to move up key and add, and then down, down key. All right, so let's play the scene and see what it looks like. Ooh, my guy's in the corner. I'm going to move our little player character, and I'm going to move it in more. And I'm also going to add to the player character a child node, which is a camera to the object, so the camera follows the player. And then I'm going to make sure this is right. This is right on top of the player. Yeah. All right. Okay. So back to our script. Um, so the inputs, the action is pressed, and that changes the coordinates accordingly. And now we want to actually move our character. So we're going to actually first set the velocity equal to the direction normalized. Times the speed. And what this does is that it gives us a constant speed no matter what direction we go in. So if we go diagonally, the character doesn't speed up weirdly. This is to prevent any bugs from occurring. And then I'm going to call the move and slide function, which is a built-in Godot function. All right, and I'm going to test this out. A little tiny, but it kind of, you can see it moving. And looks like the X and Y are swapped here, so I'm going to swap the move it up and move down. Okay, for the camera, I'm going to zoom in a little bit. So I'm going to go to make sure it's enabled. And then for the zoom itself, I'm going to zoom in 2.5, 2.5. See if that looks a little better. Yeah, looks a little better. Okay, so we have our sprites. We added animations and we added the movement, but now we want the animations to play wherever we move. So what we're going to do is we're going to add an if statement. So if velocity is vector 2.0, so if the player isn't moving, if they're idle, then we want to play the idle animations. So we want to match. Um, let's actually add a variable called last direction to say the last direction the character is looking at. If they're suddenly moving and they stop, and if we don't say the last direction, they suddenly might turn to a different direction that just looks a little awkward. So we want to save that last direction, match that last direction to if it's up, if it's down, oh, if it's left, and then if it's right. All right, so if it's up, we're gonna play the animation idle up. Oops, idle up. Down, we're gonna do that idle down animation. Left is idle left. And I'm gonna copy and paste this and do idle right. All right, let's see what this looks like. So you can see here that our uh, player character is doing its idle animation. We can move around, but as you can see, we haven't set the walking animations yet, so it's currently not facing any direction. Okay, so what we're gonna do is we are going to do the walking animations. So if the character is not Is this if it's not idle? If it's walking, we are going to check if the absolute of the velocity of x is greater than the absolute velocity of y. And this checks for horizontal movement. All right, and if it's horizontal movement, if the velocity of x is greater than 0, this means that we are walking to the right. So the animation that we need to play is walk right. Uh, and we also want to set the last direction equal to the right. All right, and then we add an else block. And obviously, if we're not walking to the right and there's horizontal movement, then we're walking to the left. So I'm going to change this to walk left. Okay, so we've done horizontal movement. Actually, let's check that out. So you can see we're walking to the right and walking to the left. Now I'm going to add the animations for up and down. So I'm going to copy and paste this, add another else block into this absolute velocity if statement. So else, then add this. And we just need to change the y value here. If the y value is greater than 0, then we want to walk down. And if not, then we walk up. And let's see if I got that right. Right, so walk up, walk down, left, and right. All right, and that's pretty much it for this activity. Some tip I have is organizing project folders. So the root folder should only have like essential files like project.godot, an icon.png if you have one for your personal game, and maybe a README. I recommend having folders for each of the different categories like your scenes, your scripts, assets, animations, and UI. You should use consistent names just to make sure it's easier to find which files and scripts are related to each other. And exclude temporary or editor files like the hidden files via .git ignore. All right, so for our first question, which is not a reason why we're using Godot. The answer is that it has minimal royalties, which is why I prefer using it over something like Unity. Question 2, which Godot node is primarily used to display and animate 2D characters, items, and UI elements using imported image textures? Answer is the animated sprite 2D. And question 3, which feature is unique to tilemap layers and makes them ideal for building levels and repeating environments? The use of small reusable textures arranged in a grid. All right, and that's pretty much for it for this workshop. Next week's topics will be collisions and object interaction, as well as NPCs and dialogue. And thank you so much for watching this video.